Yeah, good evening all. Can you guys hear me? Please confirm in the chat. Okay, thanks for the confirmation. So please wait for another 2 more minutes and we'll start the session. Okay, let people join. In the meantime, can someone confirm in the chat that whether you downloaded the ISO and the VMware? If not, please do download. So let me share the link once again. So just type bit.ly/linuxll. Okay, so let me give it in the chat as well. So this is an hyperlink or it is a URL shortener for your this one. Okay, so this is the resource page. So just go to the ISO and VMware and do download these last two files, which is of the VMware Workstation Pro 16.2 exe as well as RHEL 8.4 ISO. Okay, so yeah. And since it is a practical sessions, so you must have a working lab to proceed further. Okay, so that's the reason. Either you can use that, or I will anyhow show you how to do that in the GCP. So if time permits, we will do it today or tomorrow fully we will be doing the installation part. Okay, so today it will be only on most cases it will be on booting process. So yeah. So once again for the instruction part, so the first 5 sessions it will be of free and like means this till this week I guess it will be of for free. From Monday or Tuesday it will be only for the paid candidates, right? And this is the contact details, so you can reach out to the mail ID or you can uh, call to these numbers. And please do join using this WhatsApp link so that any communication related to the course will be shared among the group. Okay, and this is the working hours. So yeah, I guess we can start the session. Okay, yeah. So once again, welcome to the demo session day 2. So this is also a theory session. So yeah, I won't bore you with theory for the next session. From next itself, we will start the practical, like we'll install and we'll proceed with the practicals from the next session. But as of now, we'll be seeing the theory part, an important one. And let's see what it is. So the first thing is why we need to know a booting procedure, right? So why in the sense it is very, very important knowledge as a sysadmin. Okay, why? Because so that you are handling a lot of servers, and those servers you are not sure whether it will boot up. Let's say if your the server is going to a reboot, right? So it is a planned activity only, but still we don't know that whether the server will survive the reboot, right? So it might stuck in the middle, and you should know the booting process in order for you to fix. Let's say if there is any issues while it is booting, so you should know where and what to be handled or at which stage it is stuck, right? So you should know the booting process, then only you can approach that issue and you can provide a solution for that, right? So for that, at least you should understand how the booting process works, and almost it is the same for your Windows or Windows. Okay, so yeah, so let me start with the booting process. So the very first thing is, let me open a Paint, and so you have your system, right? So let's say this is your PC or your laptop. So once you press the power button, So once you press it, you will hear a beep sound, or it depends, right? So, but the process which happens afterwards is self test. So it is post it happens. Okay, so let me quickly show you this one. An image of a motherboard. Okay, so if you see here, yeah. So if you see here, it is like a CPU. Here the CPU will go, and this is where your memory DIMM slots, right? So all your DIMM will go here, means memory, and your GPU, right? So GPU, and here is where your SSD will go. And you can connect your SATA based hard disk or SSD here. And this is where your motherboard's power would be, right? So this is the 24-pin connector. And just a gist for this one. And the very important one is there is a battery in your motherboard just to power the BIOS, which is the next step. But as of now, this is the actual motherboard, and there will be a small ampere of current will be transferred to each and every component. Okay, so why? Because to just verify that whether there it is actually working. So if it is failed, let's say the DIMM is not connected correctly, and it won't work, right? If it is not connected correctly, so right away you can detect, or the very first stage itself it will be failed. So that's the reason that this post happens. Okay, so once you powered on, right away, if there is any hardware issue, like there is a failed motherboard itself, or some hard disk is failing, so right away you can understand, or you can fix it in the hardware level. And there is a, actually you can't see here, I guess there is a LED here. It is called as debug LED. Okay, so which will show you the like each stage, whether CPU is booted, whether your memory is booted, and lastly your BIOS screen. So it passed all these, then it will go to the BIOS screen. Here that it is called as easy debug LEDs. And there is some in some motherboards, there would be some numbers also. Okay, so like that. So easily you can understand whether it is a hardware issue or software issue, like that, right? So if it is in this phase, it will be a hardware issue for sure. So yeah, and the next stage would be your BIOS. So this is a very important. What is BIOS basically is basic input output system, right? As the name suggests, it is the main tool or the main package which will load all the required um which is required for your your system to be working fine. Like let's say your uh, just a sec, let me show you the BIOS screen so that yeah. So this is your BIOS screen. Okay. So this again, why I'm showing MSI is this is the actual motherboard I am using. Okay. So it is not Tomahawk. It is B40 gaming motherboard. Okay. So and this is the interface which should be mostly in the gaming sectors. Easily you can understand, and you can do a lot in your BIOS basically. Okay. So the most needed one is actually your system information, like whether how much size your memory is being installed in your machine, what is like your CPU information, your motherboard's information, and the BIOS version. That's also a very important one. And you have the all the real-time info like here, right? So what is the fan speed your system is currently running? And there is a thing called a CPU frequency and memory frequency, this one, right? So this is the one which determines how much frequency or how much speed it should be running. Your hardware should be, and it depends, right? So it depends on how much you can push and how stable you want the environment should be. And this BIOS screen is where you will edit all these, right? And the most important one is your boot priority or boot order. So here is where you will determine that what is the order you should boot your system. Either it can be, the first one can be hard disk, the second one can be a removable disk, and third one, anything. It can be of a CD drive or, and lastly, it will be network drive. So it can be, or you just follow this boot order only, and obviously you can change these, right? But most cases, this will be the boot order, and your system follows this boot order. So from this image, you can see this is the hard disk, CD drive, this is the removable disk, like that, right? So this is the boot order followed. And you can do a lot of things actually with the BIOS. I'm just skimming through these facts actually. So if I take BIOS only, it will take around 2 hours. Those many features are there in the BIOS screen. Okay. Just by changing this frequency, it is called as overclocking. And you can even underclock if it is overperforming or heating issues there. And once again, yeah, sorry to, I didn't mention that you will get a real-time temperature of your uh, like motherboard as well as your CPU, right? So if you didn't change the thermal paste on top of your CPU, so here you can clearly see there would be a spike in your CPU temperature, right? So like that. So that is your BIOS screen, and it can even fail here, but very rarely it might, but it can fail in BIOS only. Okay. So let's say you selected hard disk, right? It can be hard disk or SSD. And the full form for hard disk, sorry, HDD is hard disk and SSD is solid state drive. For the people who don't know that, right? So yeah, both are the storage solution for your system. So let's say you selected hard disk. The next stage would be what is the partition style? Either it can be MBR or GPT. You have two options or two ways your hard disk can be partitioned. That's very, very important, right? So okay, so you selected hard disk. How we can approach this hard disk? Because it is a blank disk, right? So, and it will be forming through a lot of sectors. Okay, so there are two types of which is called as MBR and GPT. So where do we differentiate these, or is there any switch for that? Obviously, no, it is a logical thing. Okay, so obviously you can either format it as a MBR or GPT, it's your choice. But mostly MBR, it is full form is Master Boot Record. And this will be used in most of the legacy servers, or predominantly it is used in your Linux and CentOS, or this kind of Linux oriented operating systems, like even IBM AX. Many you can take it actually. MBR is the most used actually. And you have GPT. So GPT is being used in GUID partition table. Even my Windows machine is also a GPT based machine. So just right click your Windows, go to disk management, and you can take any one of the disk. Go to right click any disk, properties, volumes, and here you see the partition style. It will be in GPT. So what is the actual difference between MBR and GPT? That should be your next question, right? So there is not there is a major difference. Obviously, GPT is preferred, and it like the industry also moving towards GPT, but still MBR is being appreciated. Okay, so the main use of MBR is that you can have maximum of four primary partition. Primary is a very, very important word here. So, but we will see this extensively in later session during the disk management. What is actually that primary partition is. But as of now, you can create maximum of four primary partition, but in GPT you can do 128 primary partitions. So obviously you see the real winner here, right? So GPT is the preferred one, and Windows is pushing GPT a lot. Okay, so from Windows 7 days, GPT has been like kind of a standard, especially in Windows. Okay, so that's here MBR and GPT. So we will see or we will use MBR especially in your Linux machines. So what is actually that is you have different sectors. Okay, so sectors are like this. Okay, so which one is the first to be booted? So that should be our you like if you have the hard disk as the boot drive, you might see that it might spin bit long for the first time. Why? Because it need to determine which one it should be the first to be booted. There would be a lot of platelets, right? So in the hard disk. So which one to be booted? Let's say this is the first one. So here only you have one more thing or the next boot process, which is grub screen, right? So and the boot like this boot image or grub screen will be like a splash screen. Okay, and that will be like a very very small in size. So I just to show you that I'm showing it as a very big one. It will be in like kbs. Okay, right? So 8 to 12 kb it will be that small amount this is. Okay, so the next one is your grub. So grub screen is nothing but grand unified bootloader. Let me show you here also, right? So what is grub and why we need that? And it will be booted even though if you didn't select it also, it will be booted. Let me just a minute. So you might have came across this screen uh, at least once, right? That one, or it can be of this screen like this, right? So either way, you might have came across these screens. So these are all nothing but grub, right? So which is you have dual boot or a triple boot setup, or if you don't have or like at least only one operating system, it will be there no matter what, right? So in that case also you might like dual OS. So you have dual OS like Linux or Windows. So why there is an option between Linux or Windows is so you can either boot at least only one for the current session, right? So either you can boot Linux Why? Because all your hardware will be serving, or it has its own drivers, right? So Linux has its own set of drivers, Windows has its own. You can't use simultaneously both. Obviously, you can virtually, but not as a the base OS, right? So that's what you can choose between either Linux, Windows, or even Mac. If you can use that also. So that's what grub screen is. And if you don't have any other, only one operating system also, you should go through this grub screen, right? So that's what grub is for. Very, very important screen. And from grub only you will boot kernel. So let me show you the kernel, which is the heart of your machine, right? So like literally if your kernel is froze or if something went wrong, this is what actually the kernel is. It is a open source one. Even if you download these, or if you if you download or create a fork of this version, right? So fork in the sense, similarly, like if you can copy this one and make your own version of Linux, and you can actually publish it. It is open source, right? There is no paywall or any payment related stuff for using any of these files. Literally, you can download now, but you see the amount of contributors contributed for this single kernel repo, right? So you see, like around 15, almost 15,000 people came together and formed this one. And this guy is he is the founder of Linux. His name is Linus Torvalds. Okay, and this is his GitHub page on there. So you see a lot of work and the stars, a lot of stuff will be. It is a very happening, and it is even lastly updated. It's like 5 days ago. So it is constantly. This is one of the repos which is updated a lot. And yeah, this is your kernel, by the way, and not the exact same one, obviously. So Red Hat has their own kernel, and we are using that. Okay, so that's what your next stage is. So from Grub, let me quickly give two options. Either you can choose Linux or Windows. Linux means it can be RHEL. Windows means it can be Windows 11. Okay, so you have two choices. Either one you need to choose. So let's say you chose Linux. Okay, now what would be the next stage? As I told, it is the kernel. And in your kernel, so why kernel is the most important one is, so that is like a root of your system where literally it is the one responsible to connect the dots. Like you have the all the hardware, like let's say you have the Bluetooth driver and all, sorry, Bluetooth, actual Bluetooth chip in your hand, but you can't connect it without a driver, right? So this is like a connecting solution for your any hardware. Like you have your hard disks and all, but still without a hard disk driver, you it won't work, and unfortunately, because it is not from the same vendor, right? So not only one vendor or only one company is building everything, right? So we are dependent on literally most of the many companies are involved. So they will build a common driver. So that driver will be automatically detected in your system. So in order to come make everything together, you need this kernel. So that will be communicating between your hardware and your actual OS or your software, right? So that's the job of your kernel. And not only that, it does the driver information. So driver info. and mostly it will be like a hardware related one. So hardware info and your software diagnostic. So those kind of things it will be performing. Okay, so yeah, that's your kernel. And if your kernel, so now you might ask, okay, if a kernel went wrong, what would be the server or what would be the state of the server? So if your kernel is not working as expected, your server will boot till here. Again, if it found some issue here, right? So again, it will go to the very first. So it will be doing a boot loop. It is called as. So again, it will try to boot this boot order. Next thing, it will try to boot MBR and grub. Again, come back to kernel. Again, still some issues, right? It will go back. So like that, it will go on forever until you fix that issue. That's what boot loop is. And your kernel will also loads the init process. So that is a very, very important one, init as well as your systemd process, or that is the first program to be executed, init or your systemd. Okay, so that is like a in your Windows, you have SVC host. One process will be running in your Windows. Even if you kill that also, again, it will start actually. So that is what SVC host is. Okay, so like that, you have some process in your background. So even we don't use that or we don't notice it, but still that process is needed for the operating system to be working fine, right? So those process will be initiated from the kernel. Very, very important processes. And that's what kernel is. And the next one would be your init process, as I told, and init and run level. So with that, the booting process itself is completed, but both are dependent actually. Okay, so let me show you why. And there is a equivalent for your init. Okay, so in your Windows, you just type system configuration. You have this screen, right? So just go to boot, and here you have some options. You have this no GUI boot. So if I check this box and apply and reboot my system, I will be going to the very old days, like the UI will be only the MS-DOS only will be loaded. And similarly, if I check this one and uncheck, or if I select this radio button like a minimal one, it won't even have a internet, right? So the network driver itself won't be loaded. So that's what this option is. And next one would be some different shell. So by default, I have the PowerShell, right? So there might be some other shell it will be powering on. And next one is the Active Directory repair, right? So you can ignore that. But the last one would be your network. So if I select this and the last radio button, then only the network driver will be loaded in the safe boot mode. Okay, so that's what this mode is. And similarly, you have this init processes. So like that, you have 6 init process in your Windows, sorry, Linux. And in that 6, so 0 is for halt. So if you right away typed init 0, it will, your server will be going to the, or it will initiate the shutdown phase. So if you just type init 0, it will start the shutting down process. Okay. And the next thing is init 1. So this is called a single user mode. So now is where we will understand that our Linux or the OS which we are dealing with is a multi-user mode. It allows. So what does multi-user mode means? So currently I am logged in as a user called as Jojo. So let's take him as an admin. So I can open a same session again with a again admin also I can open. So like that I can open n number of sessions based on my requirement. So that is what multi-user mode is. And it is like a remote session also I can do, which is like you can't do multiple remote session in your Windows server. it won't allow actually. If you open another session with the same user, it will throw error that the previous session will be terminated automatically without your consent, right? So that's what only one session will be allowed basically, but here it is a multi-user mode. So just to show you, let me connect to my VM. And don't worry about these always. I will just for your understanding, I'm showing you. I will show you how to install these in later sessions. Okay, so the server is started. So I am connecting to the same server remotely, right? So just let's wait. The SSH is a bit slow actually in your VMware, okay? So we should bear this connectivity for the first time actually. Okay, so there is a session opened. I can do whatever command I want, right? So uptime, date, and interestingly, if you see, if I open one more session, still it will allow. So this is what called as multi-user mode. The old session won't be gone or it won't be disconnected, right? So that's what it is, right? So that's your multi-user mode. And init one is single user mode, which is again called as like a console view. So only I will be the one having access to that. We will actually boot to the single user mode and see in the upcoming sessions. Okay. So how about init 2? It is, yeah, you see, it is booted. So this is also working, right? So let me close these. Let one be there. So init 2 is nothing but multi-user without network. And init 3. Okay, so init 3 will be multi-user with network. How about init 4? It is not there or it's not being used. Init 5 is your X11 or GUI mode. So if your init level is 5, then only your GUI element will be loaded. So what is a GUI element? As I told in the yesterday session, GUI is like a you can interact with your mission using your cursor and there will be a lot of icons and all, right? So that's what GUI is. And if it is init 5, then only it will be loaded, your GUI elements, right? So how about init 6? So if you type init 6, it will reboot your mission, right? So these are all the init levels or init different modes you can call it. So by default or the most used one is um, init 3 and init 6. So sorry, init 5. So init 3 and init 5 are the most used one. Okay, so the next last mode or your next level would be your run levels. Okay, so it is also the same thing, guys. Okay, so just like your init, your run levels would be so even in this notes you see same like from 0 to 6. But one catch here is so if you want to load, let's say the startup apps in your Windows, you have multiple apps. Obviously, in your mission also it will be there. So what is the purpose of these apps is while your system is booting, after the BIOS phase, it should initiate the OS, right? So along with the OS, this should also should be started. right? So that's what the meaning for startup apps is. So similarly, you have different startup applications. You can actually add that executable or that binary of that application in this run levels or this path basically. So if your basic run level is init 3, right? So that would be your default run level. And whatever process is initiated there in this path, okay, so it will be running along with the operating system. Or you can run along with the OS without mentioning in those paths. There is one more path. Okay, so don't worry about this path and all, but this path is also there actually. Okay, so which is init.d. So it is where like your kernel will be loaded from init, etc init.d. So if your process is landed here, obviously it will also will be booted along with the kernel, right? So like that. Or you can store it in etc rc.3 or something, rc.d, rc.3.d, like that, like this. Any path you can mention. Okay, so that is your run level is. So once your run level is also being determined, you can actually boot or you can see the lock screen of your system, which means your server is fully loaded, right? So that's what this is the actual booting process. Actually, we can go through too deep into like BIOS. I didn't even explain what is the CPU count, and you have cache memory like L1, L2 cache. So many are there. So if we speak about those, it will go on forever. But those knowledge, anyhow, over the period of time, once you start working and all, you gain it. But still, this is the process, right? So the first one is power on. So once you powered on, you select what should be firstly booted. So once you selected, the next one would be which partition style. And the next one is from the partition style, you have the boot sector, right? So what is the like what is the content of that is your grub screen. So in the grub screen only you can choose either any one of the operating system. If you have only one, it will be automatically selected from the grub. So once you selected, you need to load the kernel. So which is the like a driving factor for most of the components in your OS, right? So once kernel is loaded, which init level should be loaded, right? So for this init, actually you have this advanced boot option in your Windows. Let me show you that. So even this also like your init. Just a sec. Yeah. So here you see the fourth mode, enable safe mode. The fifth one is enable safe mode with networking. Sixth is like a safe mode with command prompt, like that. So similarly, you have different init levels. Okay, so you should choose that, and it should be a default one for the time being. You can obviously go back and change it. It's your choice, right? And you init 5 is your GUI mode. Init 3 is your multi-user with networking. And before that, sorry, after that, you have run levels, and it follows the same run levels only. So it is like a startup apps. So whatever application you want it to be loaded, it will be loaded in this run level. So once everything is loaded, you will see the lock screen. Okay. So is there any doubts, anyone? If not, we will proceed with the installation part. But before that, again, one more theory is what is the difference between virtualization and containerization? We will see that. And again, it will take some time. So next session only, we will be installing the or doing the lab setup. Okay. So first thing, let's see the difference between virtualization and containers. And this is a very interesting take on the recent times. So when the virtualization is took over the infra side, is like a in the late 2000s only. Okay, so virtualization is at its peak in like at the mid or in the later time of 2000 or 2000 till 2010. Okay, so from that time only virtualization is at its peak. But later, within 5 more years or more than that, you have containerization, right? So what is the difference and why there is a shift between virtual to container in the market or in most of the companies? So first thing, we need to understand the meaning or the usage of virtualization and how important it is, especially for your IT culture. Because without IT or without virtualization, you can't, there is a lot of resource wasted, right? So let's take one by one. So you have your base OS, right? So base OS is, in my case, it is Windows 11. So Windows 11 is my base OS, and I have CPU of 8 core and 8 GB of RAM or memory, and hard disk, it's your choice. Okay, so let's take only these two. So this is my hardware specs. So now on top of this one, I install VMware Workstation, right? So with the help of VMware Workstation, I can achieve the virtualization, or this tool is the one responsible for creating or visualizing this, sorry, virtually using this CPU or my memory. So how, in the sense, or why it should be your question, right? So let's see both. So on top of this only, I will be installing Linux, right? So Linux, especially RHEL. So the Red Hat variant of the Linux. So now is your question. Already I have an operating system, but still I need this one on top of that. Why? Because so let's say I want to run an application which will be running only on a specific operating system. The requirement is that. Okay, so only specific one, especially in Linux, it will be running. So in order for me to achieve that, I need to build a separate software, sorry, separate, I need to assign all these like a separate CPU, memory, and work on it, or I can do a dual boot, right? So I have two options, but s- since this virtualization is enabled in my mission, virtually I can use these resources, right? So it is called as the resource sharing. So it will be happening in this layer, resource sharing. So what that means is it will be sharing the existing resources only, like same 8 core CPU. I can lend few CPUs to this one, and it will be using only for that time being. And once I'm stopped or suspended that one, it will be back to my base OS and it will be serving its purpose. So like that. And all are happening in the virtual environment only. And on top of that only, I'll be installing whatever tool I want, like let's say HTTP D server, right? So anything, it can be a FTP server, right? So in order to achieve or install these, we need to install all these. And this is where the issue is, right? So I need all these layers in order to achieve this small tool. So this small tool is the key part here. Why? Because in order to install this, just it will be like let's say maximum of 50 MB, right? Let's say even 1 gig also. Still, in order to install that, I need to install a 10 gig operating system, and I need to allocate some space for that, right? So for that, I need to like allocate 20 gigs in the hard disk level, and like that, the usage goes on. And there is one more issue in the virtualization. So it is thriving, and most companies are already using it. But the issue with this one is, let's say if I have a colleague, and he's also need to use the same HTTP server, but the issue is the same version. If you want to achieve, you need to install all these. So that would be taking some time, and he should be installing correctly. So if there is no driver mismatch and all, then it's fine. But if so, he need to figure out itself, right? So he can create using a clone of this one, but still it is a lot actually, right? So in that case, you have containers. So what is a container, right? So this is a like a early 2010s or those time only. This is started, right? So it is kind of like a seeded during those time. So same Windows 11 only, but the catch is on top of this one only. So you have Docker. So Docker for Windows, right? So if you have Docker for Windows, on top of that, it is just a tool, but the power of the tool is the Docker engine. So that is the one which will be converting all your tools or softwares on top of that. So what is the software or the image? So this is where your image comes in. So you have, let's say this is your container. Inside a container, actually there will be image and the respective libraries and the drivers and all. Okay, so this image can be a HTTP server. Okay, so this is a Docker image. So what does a Docker image does? But before that, what does the Docker engine does is, okay, let me explain image, then we'll go back to that one. But before that, let's see the hub.docker.com. So here, um, let me search for Apache. Yeah, HTTP package. Like that, you have so many images, official images in your um, Docker Hub. It is an open source software, by the way. So what is the use of Docker Hub is, instead of using a full-fledged version of this software, right? So not only Apache, guys. So even any tool you can use here. So let's say you have Ubuntu also, the same image will be there, right? So this is not a full-fledged operating system, but it is not a very bad one either. It will have all the important shell, the file system structure and all, but it will be in a very small in size, right? So that's the use of containers, and you can even download the latest version, or you can pull the latest version from the internet. That's what the use of image, and this solves this like versioning issue. So the version, you can simply for in order to achieve this version, you need to be in the same version for the rest of the levels or steps, right? Whereas here, you can simply share this container with your colleague, and he will be having the same level of versioning. So there is a no issue with the versioning and all, right? So that's the main usage or main selling point for containers. And one more best thing about containers, it's already resolved the libraries. So there is no need for the dependencies also. So let's say in order for any game to be running, you need to install DirectX in your Windows, or else it will throw some pop-up error, right? So DirectX is not installed, or some runtime error it will be throwing. So in order for that to be avoided, some library files should be already in place in your Windows. Like that, some library files are needed for some of the tools. So those also will be created or taken care by your Docker engine, right? So it will be automatically creating it and it will be bundled in your container. So cumulatively, this is called as container, the inside boxes. Okay. And it is like a zip file or you compress a directory, right? So it is similar to that. Almost every important thing is in that package itself. So that's what containerization is and virtualization is. Okay, so that's the main difference. And once we see the containers, we will see extensively what is the actual meaning for those things or how to install it. But that's the difference. Okay, so with that, today we saw both the booting process as well as containers. Okay, so is there any doubts, anyone? I guess someone raised the hand. Yeah, yeah, you can unmute yourself if you want to speak, or you can drop a note in the chat. Chinna, actually, you are eligible for the like experience. Okay, so let's say if you complete the course, it is like a 2 years experience, whatever he will be performing in a work environment, right? So that's what we will be seeing. So you can't right away mention as 2 years experience, but you will have the knowledge of 2 year experience, guy. Okay, but yeah, you will have that knowledge for sure. I can assure you that. Sorry, we can't hear you, Len TT. So let me just show you one more time the payment link. I will share it with you guys. And if you are fine with my way of approach, you can pay for the sessions. Okay. So just a sec. And if there is no doubts, okay. Yeah, you are unmuted, Lentity.
I've got a question. Can you hear me?
Yeah, I can hear you.
Okay, thank you very much. Sorry, I'm very sorry. My internet has cut.
Again, we
Then I have
lost you.
to use the alternative internet. Yes.
Okay.
Yes. I'm just want to ask. I see on the virtualization,
Uh-huh.
more resources is being used, like the hardware resource. And my
Okay.
question is on the container containerization.
Uh-huh.
Yes.
Containerization. Yeah. Tell me.
Yes. Yes. So, and you have given the example on the Windows.
Mm-hmm.
Does Linux support the containers? And then where the what the image, is there any
Okay.
resources being used on the image?
Okay, so the resources, okay, so that is a good question. So in
Okay.
virtualization, I mentioned as CPU and memory is being used, right? So here, the resources will be used. Obviously, it must be used or it should be pulled from anywhere, right? So it will be pulled from our base machine only, but it will be used very minimal. So that's
Mhm.
what I told. So the let's say this Ubuntu example only I will take. Just a sec. Yeah, so this Ubuntu, it will be like a 200 MB. So the actual OS would be like a at least 3 gigs or more than
Mhm.
that, right? So at least 2 gigs it will be, but here it will be around very less in size. Why? Because it is like a bare minimum of that actual tool, right? So it is like a Ubuntu OS is there,
Mhm.
but it is a very bare minimal one, like a very basic one, which just solves that issue as of the time being. So let's say you want to perform only a basic task with that, right? So let's say you want to run a health script, right? You need a simple operating system only. There is no need any other elements to be loaded. So it will be like a very bare minimal one, and it saves a lot of your resources. Like your memory will be less used, right? It is not a whole operating system like this. So here, you see, there this OS is currently running actually, right? So which
Yes.
is consuming my memory, and everything will be spiked up as of now. If you see, it is like a
Mm.
91%, and the
That's
CPU
it. Yes, I
since
see that.
yeah. So the point is here, the virtualization is good. Obviously, it is a very important concept, especially for infra level. But there is a issue is the resource will be fully utilized, whatever resource you allocated to it. Whereas in containers, it will be used obviously, but in an optimal way. So which is appreciated, especially in an infra. So you can use multiple containers in a single in this space itself, right? So that's the use of containers and in your work environment, right? So it is like a both virtual and container combined, it will be used. So on top of this virtual, there will be some containers installed. So it is like most companies already adopted virtualization, right? So right away they can't from scratch they can't obviously they can create for the new applications for an existing one, which is an like a best practice as per the industry standards, right? So in that case, they implement few applications like a containers. So simply they can use that a new application or already they are in most companies are in migrating phase, but still as of now, it is like a combination of both virtual as well as containers. Okay. So in order to answer
Mm.
you, it will be using the resource from the base OS, but a very minimal one. Compare
Okay.
it to this one, it is very fractional, very less in size. Yeah.
Okay. Thank you. All right.
Yeah. No
That's, I think
problem.
you answered my question. Thank you.
Yeah. No problem. So yeah, this is the link for the payment. So if you understood my way of approach, and trust me, guys, it will be like just for the time being, it is a like theory part. Fully, we will be seeing only the practicals. Okay, and once again, for the people who didn't install it yet, so sorry, who didn't downloaded it, in the next session, obviously, you will install it. So you just go to resource, and let me send this link once again in the chat. Go to ISO and VMware and download the last two files, which is like a executable for the VMware. So this is what we're going to install, this virtualization, right? So VMware, and last session we'll be seeing the containers. Okay, so we will be seeing that both, and this is the ISO or the OS actually. Okay, so and if you're having hard time installing, you can just drop an mail to the support@Logic Labs. . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 。 . 。 。 。 . 。 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . Okay, so you can drop a mail to this one and they will connect with me and I can install on your behalf. I will take control of your system and it can be installed because without a working lab, you can't proceed further. Okay, so yeah, in next session, the agenda would be to install. And if time permits, I will be starting the sessions like what are all file systems or what is shell. So those kind of basic questions will be there. So we will answer all those. Okay, so it's already time. I guess we can wind up today's session. So if there is no doubts, then thanks all then. Thanks for your time. Let's see you tomorrow at the same time. Okay. So thanks all for your time. Have a great day. Bye bye.